Hi friends, welcome to CodeNet, and today we want to understand the practical implementation of linked lists. A linked list, from our previous sessions we've discussed that it is definitely a data structure. It is a data structure that is of course familiar to the arrays, but it is way different because with linked lists, they work with what we call pointers, which definitely work in conjunction with memory addresses. Hence we want to understand from the theory that we've had so far, how can we implement practically a linked list? I'm sure you can even tell from the screen. You can see that I have a code. Of course, there are a number of statements. You can tell we have line 57 as the last line. And so we'll discuss each and every statement, each and every line for we to understand what is definitely happening and how we can implement a linked list. You can double check the description. The code is ready for download for those who might want this code to be downloaded. So here I've of course included the IO stream, like from the discussion we've had so far on the introduction to C++ as a course. Here we just included a library, a common library, which allows us to work with the input and output stream objects of this code. So definitely this is what we've done from here. And here, this is just a comment, the inline comment. You can understand that if you go on our sessions for C++. So what we've done so far is, this is the beginning of the actual linked list. This is the declaration of a linked list. From the basic, simple or elementary C++ as a programming language, we said each and every variable needs to be declared before it is to be given a value. The same happens to linked list. The actual syntax of it as a data structure needs to be declared. Hence, this is what this code is actually doing. So we are saying struct node. Struct, of course, the normal thing, structures, data structures, and everything related to that. And the name, we are giving it a node. Hence, we are declaring a node and the actual syntax which a node should contain. So we are saying, okay, this node should contain two parts. The first part is the part to hold the data. Of course, you can tell it is, of course, a variable which has been declared using simple data type. And that type of a simple data type is simply int for integers. So here, if you want, you can specify, is it a string? Is it a character? Is it a boolean or anything related to that? So what we've said so far is we are making the first part of a node, and the first part will be called data, which is based on simple data type. And the second part of this node should be called next. That is the name we've given to this variable. But this variable is not dependent on simple data types. Why are we saying so? It's because we've used a pointer to declare this variable. Hence, this point or this part of this node as a node to a linked list, the structure, the second part will be holding to memory addresses. This is why we are saying from our theoretical understanding that a linked list will definitely hold the memory address for the next node. Also, the next node will hold the memory address for the other node. The other node will also hold the memory address for the fourth node. This is what linked lists are. So here you can even tell that we've even terminated the actual declaration with a semicolon. So we shouldn't always be forgetting terminating the actual declaration with a semicolon. So this is what has happened so far. Now, apart from doing the declaration, because here we've not made any node, we've just declared the actual syntax which each and every node that will be being made should be following, and the content that it should be having. Declaration. So apart from this, what else can we discuss in this code? So you can tell that head from this comment is a global variable. When we say global variable, it means we want to make a variable that can be used by any function that we can declare inside our code. So of course the main function meaning can use head as a global variable. This is what we are even denoting in our comment. And to declare head as simply a global variable, we need to make that variable not based on a simple data type. It should be based on a pointer type of a data type. Why are we saying so? Well, the answer is simple. It's because head will be keeping the memory address for the very first node of a linked list. Since head will be keeping the memory address for the very first node, then definitely it should be a pointer because it is also dealing with memory addresses. Hence, this is what we are saying. Okay, I'm making head as a variable and it is not based on a simple data type, but of course that multiplication sign is actually denoting that we are making a pointer based variable, which is head. And right now head should not point to any node. Why? Because we've not created any node. Even on the declaration, we are just declaring the actual syntax which a node should follow. So here we are saying, okay, I'm creating a global variable, but for now its link, the point at which it is pointing to, is equal to now. It is not pointing to anything. At default, head will equal to now. So that is what we've done definitely. So again here on line 16, you can tell that we have another code that needs to be explained. The code that is of course moving from line 16 to line 25. So this code is simply the insert function. A function, of course, you can tell or you can understand more about functions if you double check our sessions on functions in C++, because that was the elementary course that we need to understand before we proceed with data structures. Else, let's continue. So here we are saying, okay, I want to implement a function that will be inserting or inputting a value in this linked list that I want to implement. So now the function I want to implement is called a void function. There are two types of functions: the function that returns a value and a function that doesn't return a value. For example, the many function, int many, the many function we'll discuss, it is a function that returns a value. Hence the return 0, the value that is on the very bottom as the last statement in the many function. Now this type of function is a void function, hence no need to return a value. And the name of the function is called insert. Insert, the name should be descriptive. I mean, you can give it any name. And we are saying, okay, I'm implementing an insert function, the function that will be sending values to each and every node that will be being made as we proceed with our executions. And the values that will be being inserted into the linked list that we will be implementing is simply the value that will be coming from the main function. Hence, the implementation of a parameter, the parameter which is based on a simple data type. Hence we are saying, okay, int value, that's the parameter that will be receiving the value from the many function, and this parameter is a variable that is based on a simple data type int, integer. Hence, if the values you'll be inserting into the linked list are values that contain names, I mean, you can use any data type. It could be a string, it could be a character also, or it could be a boolean type. Now with me, I'm using int as a simple data type which will stand in for integers. Now on line 18, there is another statement which we can explain again. So here, this is where we are creating now a new node. This is the statement that will be creating nodes as we proceed with the execution, or as we continue receiving the values that will be making up nodes in this linked list. So what we are saying, okay, I'm making a variable which is called node p. I mean, I just used node p since we are making nodes, hence the name should be descriptive. And this type of variable is based on a pointer, hence the use of a star and of course the node, as the node that was declared from the declaration of the actual node and the syntax that it should follow, hence sticking to the actual word which is node, and of course the multiplication sign, meaning we are making a pointer based variable. And now the very code that allows us to create each and every node, each and every new node, for as long as we are receiving values that are coming on the parameter of value as a simple data type, is the code which is called new node. It is a key statement in data structures and algorithms with C++. In C, many use the keyword malloc and all other definitions that are associated with it. But in C++, we need to be using the keyword new node. The node is simply the actual node, which we've declared as the actual syntax that it should follow, and then we also open the parentheses, though no need to pass in the parameters, or of course to make it receive some arguments coming from a certain function. No need. So this is what this code actually means. Once we receive a 14 as a value that needs to be inserted in this linked list, then a new node will be created. Once we receive 27 as a value that needs to be inserted into the linked list, then a new node will be created. This is what this line or statement definitely does. And from here, we can now start inserting the values and of course the link to the next nodes depending on the syntax that was defined on the declaration of a linked list. So what we are saying is, okay, node P, since we've created the variable which will of course denote the actual node that is being created, so we are saying, okay, node P, and this is an operator like we understood from our previous sessions. Node P, the first part, which is called data, let the value that has been inserted into this insert function be sent on data. And on link, let now the actual reference that is on head, because head takes note of the link to the first node. And then we can tell, okay, now how will head now just keep the memory address for the very first node? For the newly created node, the node that's next to head, well, it's by defining or by sending or by saying head is equal to node P. So this is what this definitely does. And then we even close with a curly brace. So from here you can tell that we've definitely created the insert function, which is the function that will be inputting values into our linked list, the linked list to be created. Another function that we need to create is simply the function that will allow us now to display the total content, the total number of elements that are inside our linked list. And this type of function is also a void function. You can tell void, and the name of the function is display, and then you also open the parentheses. We are not receiving any value from the main function or from any function, hence the parentheses should be empty. No need to pass in any parameter. We even open the curly brace. Of course you can tell we've opened that, and from here we now want to create another variable which should be equal to the type of variable of head. What are we talking about? From our theoretical understanding, we said whenever we want to work with head, whenever we want to traverse each and every linked list, we need to make sure that we pass through each and every node for we to display the content. That is what traversing a linked list actually means. Now we can't use head to traverse a linked list. Why? Because immediately we use head, then we will disturb the entire linked list. Hence we should create a different variable that we can use for we to traverse each and every linked list. And this is what we are doing. Okay, we want to create a different variable now. Struct node, and the type of variable created is temp. This is definitely a pointer based variable because we can see the multiplication sign, of course, and of course the node from the syntax that we've declared on the very top on the declaration of a linked list. And we are saying, okay, this is also a new node, because immediately when we do this in C++, then we are just denoting that I am creating a new node. Now this should equal to the value that head is also pointing to. Hence this is why we are saying temp as a pointer based variable is equal to head as also a pointer based variable. Now we want to print out all the elements that are in our linked list. I mean, we can use a while loop if you want this to happen. If you want to understand from scratch how while loops work, please check the description. There is a link that will send you to that respective video on our introduction to C++ here on CodeNet as our courses. I mean, we enjoy programming, hence we have all the programming languages that you need. So we can use a while loop. So this is why you're saying, okay, while temp is not equal to now, while list, we've not reached the very final node, because the final node, I mean, it is the node that will be equal to now, because it won't hold on to any memory address of any next node. So while list temp is not equal to now, please print out, or please see out as a keyword in C++, please see out temp and an operator, now the data, because we understand that each node will have two parts, the part to hold the data and the part to hold next as a link to the next node. So print out the data that are on the first parts of each and every node that has been created. We even end the line. And for we now, we can tell that, yeah, so this is what is allowing us to print out each and every data inside each and every node, because we are advancing as we traverse our linked list. This is what this code does. Temp is equal to temp, of course an operator, then next. So what we are saying is, okay, once we print out the data in the first node, then the temp, don't forget, is holding on to the memory address of nodes. That's what we can say. Now proceed to the next node. After that again, okay, after printing out the content in the second node, we use the actual memory address for that second node and print out now the value in the next node. We are advancing our linked list. We are advancing, of course, as we traverse our linked list. So this is the actual implementation so far. Now, what is in the many function? The many function, you can tell int many, of course, the basic syntax of any C++ program, because this is data structures and algorithms with C++. You can tell into our many function that here we are just calling our insert function, and this function we are even inserting a value, the value that is being sent as an argument to the parameters that are on the insert function as simply the parameter, which is called a variable based on int as a simple data type. So this is what, okay, we are sending 45 to the insert function. Again, we are sending 637 to the insert function. We are inserting values inside our linked list. We are again sending a 3, sending a 90, a 12, and a 347. So now we are saying, okay, see out, values inside this linked list are, we are even calling the display function, because we understand that since the display function is also accessing head which is a global variable, then the total content that are inside our linked list will be displayed. Let's try to run this code, definitely Control S to save, and when we run this code, so we'll see that the values will definitely be displayed. And this is what we are saying, okay, values inside this linked list are 347, 12, 90, 3, 637, and 45. Hence, we've implemented practically a linked list. Hence, this is how we implement a linked list when it comes to data structures and algorithms in C++. Please don't forget to subscribe, and let's progress on our next session as we understand another new type of a data structure, which is called a stack. Don't forget to subscribe as said earlier, and you are on CodeNet.